Hello and welcome to Securing Your DevOps Transformation. I'm April Edwards, and today we're going to talk about your DevOps transformation and why it's really critical that we look at security at the forefront of our DevOps transformation. So who am I? I'm a senior software engineer here at Microsoft. I've been at Microsoft for about 2.5 years now, and before joining Microsoft, I worked a lot in the Azure transformation space for various partners across the globe, delivering projects to customers just like yourselves. I can be found on Channel 9 doing various videos on Terraform. You can always reach out to me on Twitter or LinkedIn. So let's talk about what is DevOps. Now, if I were to sit in front of all of you today and ask each and every single one of you individually, how would you define DevOps? I guarantee you I'm going to get a very different answer from each and every one of you. So let's start off with how we define DevOps. This is something we use here internally at Microsoft, and I also use in front of customers as well when we talk about DevOps and their journey. We define DevOps as the union of people, process, and products to enable continuous delivery of value to our end users. And that word value is really important because yes, we're trying to ship code, we're trying to ship software and products, but what value are we deriving? And that's what we need to keep at the forefront of our minds. So why is DevOps important? Firstly, your competition is already doing this. It increases your velocity as an organization, it reduces your downtime, and it reduces human error. DevOps has been known as a theory for such a long time, but we have hard statistical facts, thanks to Dora, that can show us what high-performing DevOps companies can actually achieve. So we know that they're going to have over 200 times more frequent deployments. They have a faster time to market, and they're going to have increased revenue, which are all things we want as organizations. But more importantly, we need to be able to commit to deploy faster. We need to have a lower change failure rate, and we need to recover from incidences a lot faster. You think of organizations like Uber and Domino's. Look how they've taken the market to hold. For those of you that used to, go to a Blockbuster store, now we use Netflix and we order things on demand when we want them. And these are a few examples of high-performing DevOps companies. So I want you to take a look at these companies listed here. We have Uber, Verizon, Capital One, GoDaddy, Equifax. All of these organizations have had a breach at some point in time, and you probably have read about it in the news. Let's take a look at Uber. Back in 2017, the two attackers went in and got some access to a private GitHub repo used by some of the Uber software engineers. They found some login credentials. They were able to access data on a cloud account that had been kind of left open with password credentials. So they were able to handle some computing tasks that Uber was using in the cloud, and they would get some archived data of rider and driver information. Now, this breach affected 57 million users, and you may have been one of them. Now, to get through this breach and to have this payout, Uber had to pay over $100,000 to have that information deleted that these attackers held ransom. Now, we look back at what went on in this situation. There were passwords in a GitHub repo in plain text. It wasn't secure. And then it was deployed to the cloud. And it absolutely was not the cloud provider's fault. Now, let's look at Capital One. When they had their breach, they had a misconfigured firewall. They had a backdoor entry point, which allowed access to their servers. And the breach occurred for months. It took Capital One's teams months to be able to identify that there was a breach, and then much less respond to it as well. And then let's look at Equifax. They had a web portal hacked. They had some passwords that were stored in plain text, and there was a lack of patching on their environment. So those two things combined left them exposed and enabled a breach to occur. Now, why did these breaches occur? We know that 95% of cloud breaches occur due to human configuration mistakes, human errors. And at each of those examples, a human made that mistake. Not maliciously, just we're all human. We all make mistakes. Think about how many times a day you might mistype something in an email or a text or online and then realize you type in a web address wrong. It's really simple to mistype IP addresses as well or to confuse IP addresses. We're all human, and these are all human errors. And a lot of times when we're delivering, we miss things because we have a deadline to meet. How many of you in your organizations have a deadline? You have that deadline. Your boss is breathing down your neck. You have to get something delivered. You do everything you can to get it over the line. I know I've sat there with my boss breathing down my neck going, I need this in 2 weeks, or I need this in a week, or I needed it yesterday. Those are the most feared words of any IT person's head. I needed it yesterday. Of course you're under pressure. So you kind of do some things that you hope no one kind of finds out about, and there might be a little bit of a shortcut, and you think, oh, you know what, I'll just fix that later. I'm just going to quickly make this change or quickly do this, and everything will be fine. We look at quantity over quality in these instances. And we have very manual processes just to get this over the line. And that's where we make mistakes. And what hinders security innovation in these organizations? What are things that bring? Yes, deadlines absolutely contribute to it. But we take a look at these lists here of things that may contribute to what hinders us in these organizations. And doing all of these things are not DevOps, and they're certainly not DevSecOps. In all of the cases that we've kind of talked about, security is an afterthought. And in a lot of organizations, we all know that. We're asked to how a product's secured, how are we going to secure it down? And we think, let's get it delivered, we'll secure it afterwards. We hinder our own innovation, and we make it difficult to think about security. We have this we'll do it later approach. We need to remove blockers within our organization, and we need to take what hurts the most in our organizations and start there and address those. Maybe it's a cultural or maybe a manual process that your organization has, and maybe that's where you need to start. Is it a cultural shift in how the teams interact and how they work together? Is there friction in the teams? And maybe because you do have that security person breathing down your necks, rightly so, they want to make sure everything you deploy, whether it be on the cloud or in-prem, is secure. And maybe your organization's giving, your ops teams and your dev teams some kind of metrics to deliver code. Maybe that quantity is being forced on them and not always quality. We need to make sure that we're using the right tools, we're developing strategies, policies, and procedures to not only prevent a breach, but also how we respond. Because it is inevitable. We're going to have a breach at some point in time. So let's talk about DevOps as a 3-stage conversation. Because remember, we're trying to deliver value to our organization and our end users. And now there's not one magic tool that will get us there and where we need to be. I mean, it'd be great if I could wave a magic wand and we had that tool, but it doesn't exist. So we really have to have this 3-stage conversation. Firstly, we got to talk about the people. The people change, the cultural change in an organization is the toughest thing to talk about, but it is the most important. The change needs to happen from the top of the organization all the way down to the bottom. Everyone in your organization needs to be involved, delivering that value. We need to think about the people, and they need to have roles and not just jobs. And then we start talking about the process. Is your organization working in a waterfall methodology now? Maybe you want to look at Agile or Scrum and where you want to go. What does your process look like today? It should be iterative. It should be cyclical. You should be able always making changes in that process. And then what kind of tooling and products are you using? These tools and products can really help us plan. It helps us check in our code, automate things, run tests, and automate our deployments. These alone won't fix it, but all of these 3 stages together will help us deliver DevOps and help us deliver secure DevOps. So let's talk about the people factor. We've all been there. As a developer, I've thrown my code over the fence because I'm trying to meet a deadline and say, that's great. Let QA deal with it, or let ops deal with it. I've delivered my timeline. It's all going to be fine. In a lot of our organizations, our operations teams are measured about delivering uptime to the organization. Are the servers and all the lights turned on? And are they healthy? That's how ops teams are measured. A lot of times the devs are measured on delivering features. So we have conflicting things that we're being measured on and conflicting things that we're trying to work on in an organization. So of course, devs are selfishly going to say, I've got my code, it works, throw it over the fence. Ops team goes, great, my problem now. So we really need a mindset change in our organizations. We need that executive buy-in. We need from that top to bottom buy-in. We need a shared responsibility model within our organization and across our teams. We just don't want to throw it to the next team. We want each team to have ownership in the process and in that tooling. We need to break down the walls between our operations teams, our development teams, and our security teams. And most importantly, we need to involve all those teams together early on in the planning, and they all need ownership of their parts of the puzzle and whatever value it is we're trying to deliver. So let's talk about the process. We really need shared responsibility through the whole process. And the process is cyclical. It doesn't just end. Because we've delivered something successfully or we've automated something, the process unfortunately is not done. We have to make it better each and every time. We need a definition of done, maybe when we're delivering something, but the process itself is continual. We need to go from this planning phase. We need to be proactive. We need to start there. We need to involve security in the plan. What is our plan for this next project or this next piece of value we're delivering in our organization? We need to be proactive, start there. Then when we build out our code, we have security built into our code. Then we go to those build and test phases. That security is already baked in and we can do other security tests, maybe unit tests. Then we go into the release, deploy, and the operational side. And as we move through this cycle, and then we have this monitoring piece. The monitoring piece is really key because that allows us to get honest feedback of what is going on in our, in our code or in our environments. And then we can become an iterative process going into the next planning phase or the next sprint cycle. Those are really important key things. So we have this phrase that we say, shift left in DevOps, right? Now, why would we want to shift left? Now, this is a great visual. Now, have a look at this for a minute. And we see, great, there's all sorts of numbers here and pretty lines, but let's get to the bottom of it. So we knew from before that 95% of, mistakes in the cloud are human errors, right? But we also know from this that 85% of defects are introduced in our code. They're introduced early on. And when we say, we'll deal with it later, we let them move forward, it becomes a snowball effect. We need to ensure, instead of letting that snowball, we push our quality upstream. Because if we look at this graph, to address the cost of fixing our code is, a one-time cost of fixing our code. And we address things early and often. If we leave that broken code or leave that issue earlier on in the process, it increases the cost in production 640 times more than fixing that error in code. Now let's think about what is a cost of an outage or security breach to your organization. You have monitoring costs and you have incident response times that we need to think about. And we need time. What's our time to recognize an actual breach? And then how do we remediate those things? Because that cost really plays into those things. All those things feed into that and say, right, how long does it take us to respond? And what's the cost? Maybe the manpower, an hour's time to fix these things. You also have to look at, if you do have a breach in your organization, do you have to pay out to get your data back? Do you have to pay for bug bounty hunters? Are you in a highly regulated industry and you have to pay regulatory fines? We deal with customers day in, day out that are absolutely in these industries, banking and healthcare. Are you delivering an SLA to your customers? What's the cost to your organization when you breach that SLA? But most importantly, when there are issues in production environments that your customers see, you have a loss of customer trust, and that has year-on-year implication. And that's not something that can be easily fixed or repaired. So companies that invest early into security lower the overall cost when a breach actually does occur. And that's what we need to do when we shift left, early and often. We need to fail fast, iterate, and make it better each time in that process. So how do we secure our DevOps journey? So let's talk about day one. So good news, bad news. Let's start with the bad news. Security started yesterday, and it never stops. It's going to be ongoing. But what we can do is looking how we can keep our surface attack area low. We can automate early because we want to free up our security professionals for bigger and harder problems, not menial tasks, not fixing code issues that hit us in production. We want to automate repetitive or similar tasks. If a machine can do it, automate it. Take away that risk from your organization and that human error potential. So the first thing we can look at is enabling secure development. Now this starts with cloning code. We need to educate and train our developers, okay? But when they clone that code onto their machine, how are they keeping it secure? Is the machine secure? Are we enabling a safe environment for our developers to code in? Are we being restrictive of them so they can't code? I mean, there's always a fine balance. And I work with so many developers that say, our machines are so locked down. We can't do anything. I can't access anything. I have developers that can't use, VS Code or GitHub or any of those tools because they're locked down, because we've locked down their machine because organizations are concerned about the development environment. So it's really important to look at how we secure those devices. Look at developer laptops. Are we using things like BitLocker? Or what happens if a device gets stolen? What is the organization's procedures for when that does happen? If you're cloning your code to your device, that's where the security starts. So we need to look at that device security as well. But we also need to look at the development environment that we enable our developers with. I work with a lot of customers where we're either doing one of the Microsoft Open Hacks, or maybe I'm on a customer site and we're building something for the customer in Azure, and we're building out some code, we're deploying something, and they're working in Notepad++. Notepad++ had its place in life, but we have such better tooling out there. And I was working with a customer recently, and they had an error in their code in a YAML file. And they took hours to find a space in the YAML file that could have been solved within a few seconds with the right tooling. So that developer environment's really, really key. What IDE are they using? We have things like Visual Studio Code and Visual Studio Code spaces. So I work with a lot of developers where the machines are really locked down and security is massive in an organization. But some of those security tools also prohibit developers from doing things on their machines that take CPU. So we use VS Code spaces so they're coding in a very secure environment in the cloud, and it's pay-for-use usage. And you can bring that kind of template of security across the different environments. And a developer can work from anywhere in the world, which is really critical in the situation we're in right now with everyone working from home. And things like VS Code have baked-in security features. We have IntelliSense. So not only are we securing the devices, we're looking at the IDE to help us enable and look at our code. IntelliSense will help pick up, code errors, especially VS Code. We can pick up those missing, parentheses or spaces or whatever language we're coding in. We can pick that up and address it there before we push it to our repository. So where are your developers putting their code? I work with developers day in and day out, and they put their codes on their machine, or maybe, and then they push it somewhere to production or a pipeline potentially. Looking at source control is absolutely critical. There's so many great products out there, no matter which ones you want to use, that have baked in features. Source control is important because we can scan our code for vulnerabilities. We can enable branch policy. So we're not committing to our main branch and pushing code to production, but we put in a branch and do peer reviews and code reviews with our developers so that we ensure the quality that they are pushing is up to the standards we need before it goes to production. We can use version control and logging. We have full visibility of what code's been pushed when and have it reviewed, have it logged, and we have that full version control so we can revert and make changes if an error does occur. We can address it in that code and make changes then and there before pushing that out to production, hopefully catching it really early. We can also secure the source control environments with GitHub. We can enable things like multi-factor authentication and Active Directory as the backbone. So we know we have that continuous security backbone in an organization. It makes it easier for it to manage. And I want to talk about GitHub a little bit because it's a really great tool. We have tools baked into GitHub, one of it being Dependabot, which is great. A lot of organizations, there's stats out there that say about 85% of organizations are using some form of open source software in their day-to-day work, or maybe even in their production environments that they're delivering to customers or out to the organizations and the end users. So things like Dependabot can scan dependencies in public repositories, and if it finds an issue, it automatically opens up a PR and it gives you suggested fixes and remediation. So it makes you aware when you've had kind of some issues in a public repo, which is great. Another tool in GitHub is CodeQL. And this is where code is really treated as data. It scans your code as it's actually created, and it scan it and review it through as it's updated and pushed into your repo immediately. There's also secret scanning in GitHub, and this is really important. So telling the story of, having Uber and putting passwords in their repository. Secret scanning will scan private and public repositories and notifies the administrators when a secret or password is found. That's great. We talk about open source projects. You can report security vulnerabilities if you're, maybe consuming an open source project that you found on GitHub. You can report that and help, improve the environment for other users and yourselves as well, and flag that. So all these different tools built into, things like GitHub remove that manual intervention. And when we start looking in the operational side and we want to use infrastructure as code and source control for our operational teams that are deploying code into the cloud or on-premise with things like ARM templates or Terraform, when we start using infrastructure as code, we can enable security from that build. So we're not having to manually deploy from maybe the Azure portal or doing something by hand and point click. If we use infrastructure as code, we can enable that build, bake in the security, have the security team review that in our code from day one, and then we can execute that code multiple times to multiple environments, preventing manual errors because we have a known good working build and template ready to go. So that's where source control is really, really crucial in securing your DevOps transformation. And let's talk about CICD tooling. Now, we talk about CICD as continuous integration and continuous delivery. I want to bring up another idea here. Continuous security. Whatever CICD tool it is you use, baking in that security to the CICD tool is crucial. So think about our continuous integration pipelines. We're pushing our code to source control. We're pushing into our continuous integration to check our code in. This allows our deployments to become repeatable and scalable and get our builds to market faster. And allows, whether we're building packages of code and delivering features or delivering infrastructure as code, we can harden the environments as infrastructure as code. We can look at the features and look at the code and check that. We can do code analysis on all of our builds in a CI pipeline. continuous delivery. We can do, all sorts of great things with testing automation. We can fail fast. This is a great place to test that in other environments, whether that be, a dev environment, a test environment, pre-prod, canary, etc. We can fail fast, test in those environments, and make those changes before it goes to production. We have all sorts of baked in tools as well to, things like Azure DevOps, GitHub Actions, where we can do vulnerability scanning, even in things like Azure Web Apps. All these are baked into some of the cloud products. When you work in the cloud, you have to think about all the tools that are at your hand to use. You just have to leverage them and start enabling them early on. And I want to talk about monitoring and alerting. This is great because you can go through a whole sprint cycle and say, did we deliver value? The other thing you can look at is looking at monitoring and alerting. Your monitoring will tell you what happened, how did things perform, how did your code perform, were there any CPU issues, performance issues, was there any latency issues in your code, or maybe you're deploying some infrastructure and you had some networking complications. That monitoring will help you pinpoint exactly where those issues are. And that alerting is key because if you know what's going in your environment 24/7, you know how you can respond. So we look at some of the organizations that had breaches before. It took them months to find that. And that's because the alerting and monitoring didn't cover everything. So using those tools to go into that iterative process of DevOps is really, really crucial. That's your feedback mechanism and that's your response mechanism because a breach probably will occur. It's how you respond. So when we look at securing our DevOps journey, we can look at some tools to really help us. But let's start at the beginning of the process, looking at the development environment from our teams, whether it be developers or operational teams doing infrastructure as code. Let's secure those environments and secure how they access the code. We want to secure early and often. We want to focus on shifting left. We want to focus on that 80% of our code, because 85% of our code where we know those errors are going to occur. We want to give visibility and auditability amongst all of our teams and enable them to do so. When we start merging the applications along with the workloads and the security as a combination of technology, infrastructure, and code, there is an instant unification between our developers, our operations teams, and our security teams. So almost all cloud providers, I will say all cloud providers, have tools that are enabled in their environments. They're either baked into the products as features, either for free or at some additional cost potentially. But we can look at in Azure, we can automate the entire process from beginning to end, and we can make this repeatable. So when we look at Azure, let's look at some of the tools we have in Azure today and the products we offer. So remember, think of it like a lock and key. We give you the lock and key, you've got to enable it and put it together in your environments. So we look from the end user's perspective, the developer or operations team that's doing something. We can secure them with Active Directory and multi-factor authentication, and they can access GitHub with those and the Azure environment with the AD backbone. When they access GitHub, they can, you have that access to advanced security features and the open source security, as we kind of mentioned before, that feeds back in. And you can deploy from GitHub into Azure pipelines, which is our CICD tooling in Azure DevOps. You can also look at things like GitHub Actions or whatever CICD tool it is you use in your organization and deploying that into Azure. When you deploy that into Azure, we can deploy into our environments. We can hook in Azure policy on top of our CICD pipeline. So we do all of our testing in our pipelines. And then we can make sure if we have Azure policy enabled to look at security in our environments and our subscriptions, maybe rules or anything else. And everything we deploy has to adhere to that policy. If it doesn't, we revert back into our pipeline and has to fix those things before we can deploy into our environment. So in this example, we're deploying to Azure, the Azure Kubernetes service. So if you have secrets and passwords, instead of putting them in GitHub, you can put them in things like Azure Key Vault. The tools are there. We use it a lot with customers when you're trying to secure secrets to the environment or passwords or any kind of environment variables that might be, that don't want to be public facing. Because again, we had those organizations previously that put passwords and secrets in plain text, and they were definite causes of a breach. And we look at other things we have in Azure today, we can secure the end user access. And then kind of at the end of this cycle here, from our beginning to end cycle, we have Azure Monitor. This is our wraparound feature to put monitoring around everything we're doing. So we have full traceability in our environment and alerting mechanisms. There's also a secure DevOps kit for Azure. This is, again, very cyclical, really great tool that allows you to provision security in your subscription, allows you to develop securely, and use these tools to kind of pick out issues that you may not have thought of or may have missed in this process. You can deploy security from your build and release pipelines. It also walks you through scanning products and giving you a single security dashboard, especially across the different DevOps stages. It's really, really handy in that sense. And you can make data-driven improvements to your security. So the Secure DevOps Toolkit is really great for those of you that are consuming in Azure today. So let's look at the benefits of securing your DevOps environments. We know that you're going to have a faster feedback loop in your environments. You're going to lower your attack surface, which is crucial. And you can do that on day one. We need to be able to fail fast and iterate that and make changes. We need to be continually improving our environments. We need to shift left and deliver that value to our end users and our organizations. I want to thank you. My name is April Edwards. Please feel free to reach out on Twitter or LinkedIn and ask any questions. Thanks, and speak soon.